Hello everyone, welcome to this course on electrical circuit analysis. Today's topic is reciprocity theorem. These are the topics we are going to discuss in today's lecture. First is the definition. For a linear network, the ratio of voltage of a source to the current produced in any part remains constant even if the voltage source and current produced interchanges their respective position. Okay. What the definition says? You are applying some voltage at one end and you are observing some current at the other end. Okay, and even after interchanging, that is the voltages at the, for example, consider this circuit. Okay, we are applying some voltage at this end and we are observing a current at this end. Okay, we are applying a current at this applying a voltage at this end and we are observing the current at this end, that is V01 and I01. Okay, after that what we are doing is we are removing this voltage source. How we can remove? By short circuiting the voltage source. Okay, so we have short circuited the voltage source and we are trying and we are applying some voltage at the end where we have observed our current. Okay, so the V02 is applied here. Kindly observe that this V01 does not equal to V02. Okay, so we can apply any some other voltage also. Okay, but we have to apply at the end where we have at the terminal where we have observed that earlier current. Okay, now if you are taking the ratio of this one V0 divided by I01, it will be equal to V02 divided by I02. Okay, so that says that the reciprocity theorem is satisfied. Okay, so here one thing is, whatever the current direction, we have to maintain the same thing. Like after polarities, we have to maintain it. Okay, here the polarity of I01 is towards Y1. Okay, and this V01 is towards X1. Okay, now we are trying to exchange. So this V02 is applied towards this I1, that is polarity of V02 is towards Y1 and I02 is towards X1. Okay, so even if you are interchanging this, automatically the current through this will also be interchanged. Okay, if we are considering this as negative and this as positive, then the current direction will be in the opposite way. Okay, this we can observe from this. This is the step which has been explained now. Okay, solve the given circuit and identify the branch currents. Okay, so for the given circuit you have to solve it either using mesh equation or nodal equation and try to find out the branch currents of the circuit. Okay, and then remove the voltage source from that branch. So, okay, so here it is X1, Y1. Okay, by short circuiting the branches, and after that try to find out the after that we have to place the voltage source. It need not be V01, it can be some other voltage source at the other end, that is Y11, which has the original current of I01. Now you try to find out the branch current at Y11. Okay, either using the mesh voltage or nodal voltage mesh current or nodal voltage equations. Okay. After that, if you are finding the ratios of V01 and applied voltage and the current observed will be equal to the applied voltage at the other end, the current observed at the interchanged position. Okay. Okay, so first, for example, if you are taking away the dependent sources. Okay, I am taking one circuit with the dependent sources, voltage of this magnitude 10 and angle 30 degree. Okay, so I am trying to do the mesh current equations. Okay, mesh current. Okay, so here three loops are there. So I1, I2, I3 are the loop currents. Okay, these are not the branch currents. Okay, so we are trying to find out I1, I2, I3. Okay, and first loop, and so what are the impedances coming across the first loop? This 1 plus 1j and 2 plus 2j are coming, so they are added up and represented as 3 plus 3j ohms. Okay, and first loop and second loop. First loop and second loop. What are the impedances coming across this first loop and relating this first loop and second loop? This 2 plus 2j ohms. The current direction of I1 is in this way, which is considered as positive now because we are considering the current loop I1. Okay, so this is considered as positive, but the current I2 is going in the opposite way, right? It is going in the opposite way. So this is considered as negative. Okay, and what is the impedances relating this loop I1 and I3? There is no impedances connecting this I1 and I3. So it is considered as 0 plus 0. Now second loop, right? Second loop. In the second loop, what we can do? Second loop connecting this I1, first loop, right? This second loop current is considered as positive now for this elements, and the I1 other elements are considered as negative because it is going in the opposite way or opposite to that of I2. Okay, so that is why it is minus. Okay, so similarly the off diagonal elements will be negative, the diagonal elements will be positive. Okay, so I1, I2, I3 multiplying with the loop currents, and we have to equate to the voltage rise in the circuit. Right? Voltage rise, it is the voltage sources, right? Voltage source is, what is the voltage source? 10 at an angle 30. It is when it is converted to rectangular coordinates, right? It becomes 8 minus 8.6603 minus 5G. Okay, and whatever the current whatever the voltage across this end is 0, so I have represented this as 0. Okay, our interest is I3 because we are trying to observe the current at this I01. It need not be, the I0 need not be here, it can be anywhere in the branches. Okay, it can be here or it can be here or it can be here, anywhere. But for example, we are taking the I01 as in this branch. Okay. Now we are after solving this, we are getting this I1, I2, I3 loop currents, and we are considering this voltage source and this branch current. So we are taking the ratio of that V01 divided by I01. From that we have observed 26.5 plus 33.5 J. What should be the unit here? It should be ohms. Right? It should be ohms here. It should be ohms. Okay. Now we are trying to interchange this one, right? We are going to interchange this voltage source over to this branch. How we can do it? First we have to short circuit it. After that we can interchange. We can place it over there in this branch. Right? We have short circuited this one and we have placed this one. Okay, I intentionally marked I02 in this direction. Okay, I02 in this direction, and we will try to observe whether we are getting the same result or not. Okay, here the V02, I have applied V02, earlier it was V01. Okay, here V02, earlier it was V01, where V01 is 10 at an angle 30 degree. Here it is V02 20 at an angle 45 degree. Any value you can take. Okay. So I am applying some voltage at this end and I am trying to observe that. See, the impedance matrix, it will not change because we are not going to change any values of the impedance. So it will remain the same thing. Okay. What will be the changes? Only in the voltage and the current, but we are going to find out the current. So there will not be any changes, like we need not change anything in this one. and we have to change the voltage here, because earlier there was a voltage at the first loop. Now the voltage is at the third loop. So voltage at this first loop is 0, so I have mentioned as 0, and third loop it is varying 20 at an angle 45 degrees. So accordingly there is a rectangular value, rectangular coordinate of that value is minus 41.1421 minus 14.41421 G. Okay. So from this we are calculating I1 loop currents, I1, I2, I3, and from there we are calculating the ratios of the applied voltage and the observed current, right? V02 divided by I02. We can observe that the current is negative value, right? Negative of this one. Okay. So we got the same value as 26.5 plus 33.5 J ohms. Here also ohms, right? So earlier it is the same. So we have verified the reciprocity theorem. Okay. So till now we have discussed about this independent sources. Okay, what about the dependent sources? Okay, to observe that, what we can do is we can have some dependent sources in the circuit. We can include some dependent sources. So here it is the dependent source voltage source is included here, 0.5 I0, where I0 is the current flowing through this 3 plus 3 J ohms. Okay, so we are trying to find out the reciprocity when dependent voltage sources available in the circuit. Okay, so now what are the changes we can observe here? See, everything, the mesh equations, impedance, mesh impedance will be the same, like whatever the impedances coming across this I1, I2, I3, it will be in the diagonal elements, and between the loop currents it will be in the off diagonal elements. So it is same as such. We can write it. Okay, what is the voltage rise in the particular loop? We can write here. Additionally, one more voltage rise will be coming into picture for this I2 loop as well as I3 loop, because this is linking between I1 and I2 and I3. So the same way it will be appearing in the equation also. Okay, but in case of I2 it is going, that is the current is assumed in this direction and it is going inside this positive terminal of this voltage source, so it is considered as negative of that. We have to take negative of that. Okay, from the voltage source, from the positive terminal of the voltage source, the current should come out. That will be considered as a positive, right? So it is in the opposite way, because every time current will be coming out of the voltage source. Okay, from the positive terminal. Okay, that's why here it is in the opposite way. That's why we have applied negative. Okay, and whereas I3 it is similar to the current flow from the voltage source, so it is considered as positive. So 0.5 I0. As said earlier, this is the equation for dependent source, and for independent sources this is the equation for the independent sources, and for the dependent source we have to have another equations. Okay, here if you are observing this I0, it is related to I2 alone. Okay, so we are taking that relationship and we are trying to apply it here. Okay, so this minus 0.5 I2 will be, we are substituting here and we are rearranging. On rearranging we can see that there is a changes in the impedance matrix. Okay, due to this dependent sources we are having the changes in the impedance matrix. Earlier it was symmetrical, now it becomes unsymmetrical. Okay, there will be changes in the 2 points. Okay, whenever there is a changes in the diagonal elements, no problem, but we are observing some changes in the off diagonal elements. Therefore symmetricity of this matrix it is getting affected. Okay, and after this we are observing V01 by I01, and we can observe that this is like 17.1923 plus 30.5385 J. Okay, now we are removing this voltage source and we are trying to apply it here as before. Okay, so it has been removed, voltage of that is removed, and the voltage source is applied here. Okay, and we are trying to observe the ratio of V02 and I02 as before. Okay, but here if you are finding, we got the value of 29.1250 plus 33.8750 J. Okay, but earlier we got 17.1923 plus 30.5385J. Okay, this is different and this is different. So with the dependent source, the reciprocity theorem will not come into picture. Reciprocity theorem, it is not satisfied. Okay, so the reciprocity theorem applies only to the independent sources. Okay, if there is some dependent sources in the circuit, the reciprocity theorem will not work. Okay, here why? Because the symmetry of that impedance matrix, it is getting affected. Because of that, the reciprocity theorem is not working. Okay, so this shows the importance of the symmetricity of the particular matrix. Okay, and these two things we need to take into account. One is, with the dependent source we cannot apply reciprocity, so we cannot apply this reciprocal theorem with this dependent sources. Another one is, like, only one voltage source should be present in the circuit. For reciprocity, what we have to do, we can apply this reciprocity only with the one voltage source alone. Okay, so other voltage sources, if it is there, then we cannot apply it. Okay, and clearly understand, this is only one voltage source, not current source. Current source will not work out here. If you want, you can check it also. Instead of voltage here, you can apply the current source here and try to find it out. Okay. And this is the self-assessment to you. Verify the reciprocity theorem for the given circuit with only 10 at an angle minus 20 degree volt sources available in the network. Okay, so what this question says, that only this 10 at an angle minus 20 degree voltage sources available in the circuit. We have to remove all other voltage sources as well as current sources. Okay, so we have to open circuit this current ampere or current sources. This also we have to remove by open circuiting this, right? So we have to open circuit this one and short circuiting the voltage source, other voltage source. Okay, only this 10 at an angle minus 20 degree voltage should be available. Okay, here also we can just remove it. Okay, so here what you can do is, instead of only 10 at an angle 20, you can have this, we can remove this one voltage source, dependent voltage source, by short circuiting it, and we can remove this. Remove this. Okay. Now you have only this 10 at an angle minus 20 degree voltage and 2 volt current source. Okay, 2V, not 2 volt, 2V current source. V is the applied voltage across this 2 minus J2 ohms. Okay, for this circuit you have to try to find out the reciprocity theorem. You have to verify it. Okay, why we are removing all other sources? Because only one dependent source should be available for testing this reciprocity theorem. That's fine. Okay, so once you have completed, you can submit it. Thank you for listening.